Welcome to This Explainer. I'm absolutely thrilled you're here today because we're diving into something we all interact with every single day, yet rarely give a second thought to. Yep, we're talking about our trash. But we aren't just looking at where it goes. We're looking at the fascinating mechanics of how garbage literally generates the electricity that powers our modern lives. The engineering behind waste-to-energy plants is a total masterclass in human ingenuity, taking a massive societal problem and flipping it into a powerhouse resource.
And that brings us to our core mystery for today. Why are major cities suddenly fighting over garbage? Think about that for a second. For decades, right, towns paid top dollar just to make their garbage disappear. It was a nuisance, a complete logistical nightmare, and an environmental hazard. Yet, out of nowhere, urban centers are actively competing for this very same refuse. Why the sudden shift? Well, consider this question a bit of a Trojan horse. To solve this economic and social mystery, we actually have to look under the hood at the underlying engineering mechanics.
Okay, let's get into Section 1, the rush for garbage.
The contrast here is honestly wild. On the left, we've got the old view, garbage as a completely useless municipal burden. Picture sprawling landfills, toxic runoff, heavy trucks burning diesel just to dump tons of waste into a giant hole in the ground. It was purely a negative on a city's balance sheet. But look at the right, the new view, garbage as a highly sought-after energy resource. The trash sitting in your bin right now is no longer the end of a product's life cycle. It's the raw fuel for a massive industrial process. And the secret driving this massive shift? It's entirely mechanical.
This entire paradigm shift was perfectly captured back on March 16th by the science and engineering account Manufacturing Principles. They posed this exact scenario, and it's a great reminder that the answers to our biggest macroeconomic questions, like why cities are suddenly hoarding trash, are almost always found in the micro details of mechanical engineering.
So, let's look at those details in Section 2, Waste-to-Energy Mechanics.
First things first, let's establish exactly what we mean here. Waste-to-energy, or WTE generation, is the mechanical engineering process of creating usable energy, usually electricity, from the primary treatment of municipal waste. Notice the heavy emphasis there on mechanical engineering. We aren't just letting garbage rot and capturing the gas, though, that is another method. What we're focusing on today is active, dynamic, heavy-duty manufacturing principles applied to everyday municipal waste. It is a highly controlled, incredibly precise industrial operation.
So let's walk through the actual steps, because this is the core engineering you really need to understand. Step 1 is incineration, or thermal processing. The garbage gets fed into these absolutely massive custom-designed boilers. We're talking temperatures exceeding 1,000 degrees Celsius. That is literally hot enough to melt solid brass. At that extreme heat, the garbage combusts, releasing a tremendous amount of raw thermal power. But heat alone doesn't turn your lights on, right? That brings us to Step 2, mechanical turbine activation. The intense heat from the burning trash is used to boil water in a closed loop, producing high-pressure steam. This steam gets forcefully blasted into a massive mechanical turbine. Imagine a giant high-tech pinwheel. The steam hits the blades, converting that raw thermal heat into kinetic mechanical movement. This turbine spins at thousands of revolutions per minute. Finally, we have Step 3, energy conversion. The spinning shaft of that turbine is directly connected to a generator. As the shaft rotates inside a magnetic field within the generator, it forces electrons to move, creating an electrical current. Heat becomes motion, and motion becomes electricity. It's just a beautiful, brutal display of physics and mechanical manufacturing.
Let's zoom out a bit for Section 3, engineering the grid.
Scaling this up, these plants represent a monumental industrial triumph. First off, they harness some serious mechanical manufacturing principles. These facilities require specialized metallurgy to withstand the highly corrosive nature of burning trash, advanced fluid dynamics to route the steam efficiently, and precision engineering to keep those massive turbines spinning flawlessly day in and day out. Second, it generates critical urban energy. This isn't just a gimmick. These plants pump massive amounts of reliable baseload electricity directly back into the city grid. The city's own waste is literally powering the streetlights illuminating its roads. And third, it completely solves the municipal waste overload. By incinerating the trash, the physical volume of the garbage shrinks by up to 90%. What you're left with is a tiny fraction of ash, which takes up significantly less space in a landfill. It's an elegant closed-loop solution driven entirely by mechanical ingenuity.
Which brings us to our final takeaway in Section 4, rethinking urban waste.
Take a look at this quote again from Manufacturing Principles. How garbage generates electricity and why major cities have started fighting over it. It really brings our whole narrative full circle, doesn't it?
Once you understand the engineering, when you realize that a ton of garbage is, for all intents and purposes, a ton of unrefined fuel waiting to be turned into high-pressure steam and kinetic energy, the whole social mystery completely vanishes. Cities aren't fighting over a burden, they are fighting over a highly valuable commodity. A city with a state-of-the-art waste-to-energy plant needs a constant, steady supply of fuel to keep those mechanical turbines spinning and generating revenue. If they run out of their own trash, they will gladly take their neighbors, because more trash means more mechanical activation, which means more power on the grid.
Which leaves us with this final, incredibly exciting question to ponder. How will the mechanical engineering of waste change the future of your city's energy? Next time you throw something in the bin, I really want you to picture the boiler, the steam, and that spinning turbine. Your household waste isn't just garbage anymore. It's a future piece of green infrastructure just waiting to be engineered. Thank you so much for joining me for this explainer. Keep asking questions and keep looking at the hidden mechanics behind the everyday world around you.